Have you ever asked an AI a question and gotten an answer that sounded so specific, so confident, and was also just completely wrong? It's not a random glitch, you know? It's a phenomenon called hallucination, and it's one of the biggest puzzles in AI today. So we're going to dive into why these brilliant machines sometimes just make things up.
Okay, check this out. This is a perfect example. Researchers asked a top-tier AI model about the PhD dissertation of an AI scientist, Adam Kalai, and it spit out this answer: a super precise title, a prestigious university, a specific year. It sounds totally legit, right? Well, the problem is, it's wrong. Every single part of it. The real dissertation had a different title, and he got it from Carnegie Mellon back in 2001.
So that brings us to the big question, right? What is going on here? Why are these incredibly powerful, super intelligent systems so good at confidently inventing facts out of thin air? The answer is really fascinating, and it has way less to do with a bug in the code and a whole lot more to do with how these AIs are taught in the first place. To really get this, we have to go back to school, AI school. See, the whole hallucination problem doesn't just show up at the end. It's actually baked in from the very beginning of the AI's education. Let's try an analogy the source paper uses because it's a good one. Just picture an AI, a large language model, as the super diligent student. But its library isn't some building downtown. Its library is basically the entire internet. Its only job is to read all of it and learn the patterns of how we talk and what we know. Now, you'd think the AI's main goal is to generate facts, to write a correct sentence from scratch. But actually, before it can ever do that, it has to master a much more fundamental skill: just judging facts. It has to learn to look at any statement and sort of implicitly answer the question, is this valid? And in practice, this is what that looks like. The AI is sifting through billions and billions of examples, playing this massive game of true or false. It learns that, yep, there are two Ds in ladder is a valid statement. It learns that greetings with that spelling is an error. It even learns that saying I don't know Don's birthday is a perfectly valid and correct thing to say. But here's where the trouble really starts. What happens when information is rare? I mean, imagine a fact, like one specific person's birthday, only shows up one single time in that entire internet-sized library. Statistically, that lonely little fact looks an awful lot like a random typo or a plausible-sounding lie. The model just struggles to tell it apart from all the noise. Researchers actually have a name for this: the singleton rate. It's just the percentage of facts that show up only once in all the training data. And what they found is pretty incredible. This rate is a powerful predictor for how often a model's going to hallucinate. The more singletons you have, the more guessing you're going to get. So this is the main point, the thing to really remember. Those spectacular, confident lies we see an AI generate, they aren't some deep, mysterious flaw. They are the direct result of a much simpler, lower-level mistake, an error in that basic is this valid or not judgment call. Okay, so the AI has a hard time with rare facts. But you'd think, as we test and refine these models, we'd fix that, right? Well, it turns out the way we test them actually makes the problem a whole lot worse. This is what we call the test taker's dilemma. Let's go back to our student analogy. The AI's done studying, and now it's exam day. But the way we grade most AI benchmarks is, well, it's interesting. A correct answer gets 1 point, an incorrect guess gets 0 points, and saying I don't know also gets 0 points. So if you were taking that test, what would your strategy be?
You'd guess. Of course you would. There is zero penalty for being wrong, but there is a potential reward for getting it right. And, as the researchers put it, this system means the models are basically always in test-taking mode. They're incentivized to bluff, to just throw out a plausible-sounding answer, because saying I don't know gets them absolutely nothing.
And this isn't some small, niche problem. This is like an epidemic across the entire field. Some of the biggest, most important AI benchmarks, MMLU Pro, GPQA, SW Bench, they all use this binary, right or wrong system. By their very design, they all reward guessing and punish the honest answer of, I don't know. So if the training process creates the potential for this and the testing process reinforces it, how do we break the cycle? Well, the paper argues for this beautifully simple solution. We don't need to completely rebuild the AI student. We just need to give it a better test. The new test has 3 super straightforward rules. First, you make the grading rules crystal clear right from the start. Second, you actually introduce a penalty for getting it wrong. That discourages random guessing. And that leads to the third and most important part. You implicitly reward honesty, making "I don't know" a safe, strategically smart answer. And you won't believe how easy this is to do. You just change the prompt. So for example, like you see here, you can literally tell the model how it's being scored right in the question itself. You're telling it the exact confidence level it needs to hit before it should even risk giving an answer. This is how you make an AI behaviorally calibrated. Its actions start to reflect its actual certainty. And this isn't just about making one model better on one test. By changing the rules of the game on these huge, influential leaderboards, you change the incentives for literally every AI developer out there. It creates this system-wide push toward building models that are not just knowledgeable, but are also more trustworthy and, well, more honest. So let's just quickly recap the big ideas here. Hallucinations aren't some weird glitch. They're just predictable statistical errors. They get started when AIs struggle with those rare one-off facts. And the bad habit sticks around because our tests literally reward guessing. So the solution isn't just to build a better AI, but to give it a much better test. And all this leaves us with a final big question to think about. As these AI systems become a bigger and bigger part of our lives, maybe the most important thing isn't just what an AI knows, but how well it knows what it doesn't know. Maybe we should start grading AI on its honesty, not just its knowledge. What do you think?